This is Bryson with Stone Security. I'm here at ISC West and I'm in the Milestone booth, and we're here looking at a product called Swear, and I have here the CEO of the company here is going to explain a little bit more about it, adding this into your product and what it does for your system here. So can you go ahead and show us and tell us a little bit about it?
My pleasure. So Swear is the industry's first technology that creates AI-resistant recordings. Why I say that is that all the technologies that we've been relying on in the security industry for the last 20 years are legacy technologies. Encryption, watermarking, public-private keys, hashing embedded directly into the video. Swear's technology is something different. What we do is we create an independent notary, which creates an independent chain of custody. The way the technology works is what technology we call digital DNA mapping. And what that is where we take the content and we create cryptographic hashes of every frame in real time that matches every pixel, frame by frame and second by second.
So this validates the video essentially 100%, right?
Yes.
Zero manipulation can occur or anything like that, right? That you wouldn't be able to detect, right?
Correct. And we store those hashes, those cryptographic fingerprints, remotely, and we protect them with blockchain. So that creates the independent aspect.
And how long are they stored in the blockchain? Is that
indefinitely?
Indefinitely. Okay.
Yeah. And it's a very low impact to the Expertech system.
Okay. And does it run on the recording server or on the camera?
It runs on the recording server. So as the camera stream, it takes about 4 to 5 minutes to install the software on your Expertech management, your files, your server, and it starts to cryptographically hash and store those remotely. Okay. We then use blockchain to protect the authenticity of those hashes.
Okay.
It's about 0.5 megabyte of data per hour per camera.
Okay.
So then later on, if you want to, you send someone 30 minutes of a video, our technology recreates the hashes and then compares them frame by frame and second by second. And if someone has modified a single pixel or actually flipped a bit in a single frame, we can tell you that 1 second in that 30-minute video has changed.
Valid. Okay.
Correct.
That's really cool. So what does that look like here inside of Milestone? You want to take a look at that?
So here we are in the Milestone. We have the Expertech. This is an export. As you can see here, we have 6 videos. On the Swear tab, what we do is we come in and we click the Verify button. What it's doing here is it's taking all the videos frame by frame and second by second and recreating those hashes and comparing to what they see out protected by blockchain. So this is a typical video. Of this one, there's 121 seconds. So there's 30 frames per second in a GOP, and we take a hash of every one of those frames and then we hash those hashes, and so we have 121 of them. And what you can see here, as we hit play, these are the hashes for a single second here. I'll just stop this. For 850 and 17 seconds to 850 and 18 seconds, it took us 0.4 seconds after that happened for us to create the hashes. Okay. And it took another 2 seconds for us to write those to our backend database. Okay. This is what the hash looks like. It's protected in our database.
So what does it look like if it is modified?
Sure. So in this video here, you'll see that there's a red section right here. When we get to that red section, what happens is the hashes have changed. In this video, we actually changed a bit. Okay. Not a pixel, we changed a bit.
A single
bit in a single frame. Okay. And it will show you that each one of these seconds has changed. Now the beauty of Swear's technology is we don't know what actually changed. Okay. And that's important because privacy needs to be maintained because the video itself never leaves the Milestone environment. Okay. Only the hashes.
Only the hashes.
And this right here, in full transparency, these are all the hashes, second by second of the video. For what second to protect, how long it took to protect it, and what the actual hash of that is. Okay. There's one other thing I want to show here, is that we have what we call a time score. If there is a delay in protecting the authenticity of the content, we want to flag that. Now it still can be authentic, but in this one here, you'll see there's some yellow. And what we did is we delayed the ability for it to write into our system. If it takes longer than 60 seconds to write into our system, our back-end system, we want to bring attention to that.
Okay.
Because time is important. We have to do this as close to real time as possible. The hashes occurred in a few seconds, but they weren't able to be preserved remotely.
Okay, that's really cool. That's a really interesting thing. I really appreciate you taking the time to kind of walk us through this and show us this. So if you guys have any more questions about this, you can reach out to us at Stone Security and we can kind of help you out with this and show you more of this. I really appreciate you. Thanks so much.
My pleasure. Thank you.